Hello everyone, welcome to ashatech.com. Once again, in this discussion we are going to discuss a question on vectors. Part A of this question says three forces F1, vector F1 is equal to 6i plus 2j plus 3k, and F2, force F2 given by 3i minus 2j plus 6k in newtons, then and F3 which is given by the vector 2i minus 3j minus 6k newtons respectively, act on a particle which is displaced from point 2, -1, -3 to 5, -1, 1. Find the work done by the forces. Let us look at part B of this question, which says a force of 3i plus 2j minus 4k newtons is applied at the point 1, -1, 2. Then find the moment and the magnitude of the moment of the force about the point 1, -1, 2. Then part C of this question says find the directional cosines of the line joining the points P, 4, 3, -5, and Q, -2, 1, -8. So let us look at the solution of these problems. So when we look at our problem, part A, we must know that these three forces, F1, F2, F3, will act on that particle to displace it from point P to Q. It means there is a resultant of F1, F2, F3 that is going to work on this particle to displace it through a displacement vector D. So vector D is the displacement vector, and RF is the resultant of F1, F2, and F3. These are vectors. Now it means RF, or the resultant force, is equal to the sum F1 plus F2 plus F3 for equilibrium purposes. And for us to get the resultant, it means we are going to sum the forces, the components of these forces in the x direction together, and also in the y direction together, and in the z direction or the k direction together. It means therefore, for me to get the resultant force, I'll get 6 plus 3 plus 2, that will be 9 plus 2, and it will give you 11i. Then it means we go to component j, so it will be 2 minus 2, which gives you 0, then minus 3, which gives you -3 at the end of the day. So minus 3j. We go to k, this will be 3 plus 6, which gives you 9, minus 6, which gives you +3, and we will have 11i minus 3j plus 3k as the resultant force. Now let us look at the vector for displacement, or the displacement vector. So for me to get the displacement vector PQ, I always say it is Q minus P, because I'm moving from P to Q. Usually the displacement will always be Q minus P in vectors. So that I have 5, -1. If I put them in column vector form, it will be 5 minus 1, 1, then minus 2, -1, -3. So if I deduce, if I subtract here, this will be 5 minus 2, I get 3. I get -1 minus 1, this will be a -1 plus 1, which gives you a 0. Then I also have 1 minus 3, which gives you 1 plus 3, and that will be 4. So this is the displacement vector D, which gives you 3i plus 4k, because the y component is 0. Now we have to take a note here that work done is energy, and it is therefore a scalar quantity which comes from a dot a dot product between force and displacement vectors. Therefore, work done is always, of course, we know that work done is force times distance. But if we have the force and distance as displacement in terms of vectors, then it means the work done will be a dot product between the force vector and the displacement vector. Therefore, for me to get the work done, it will be the resultant, because it is the resultant that is going to move this particle through a displacement d. So this will be 11 negative 3, 3, which is the vector of the resultant force. Then we dot it with the displacement vector, which will be 11 times 3, it will give you 33, plus negative 3 times 0, which will give you 0, plus 3 times 4, which will give you 12. At the end of the day, when you sum 33 plus 12, it will give you 45 joules. So the work done here is 45 joules. Now part B says we have a force and a displacement R, and they are telling us this force is acting at a point which is at R, or displacement with respect to the origin, or 0, 0. In other words, it means the origin is of vector 0, 0. Then we are taking moments about a point which is I minus j plus 2, that is 1 minus 1, then 2. So it means if I'm to get a displacement here, it would be this 1, negative 1, then 2 minus 0, 0, 0, which is the column vector of the origin, and this will give you 1, negative 1, 2, which at the end of the day gives you R, which is I minus j plus 2k. So that means, since we know that moment takes place in a particular direction and it has magnitude, that means this moment is a vector quantity. So it comes by vector product, or what we call the cross product. We are saying moment takes place in a particular direction. Remember, it has also a magnitude. So since it comes from force and distance, or displacement, it means since the moment itself will be a vector quantity, it is informing us that actually what we are going to do for us to be able to get this moment is to cross R and F, so that R and F, or the moment, becomes a cross product between the force vector F and the displacement vector R. Therefore, the moment of F about that point, about a point at a displacement R, will be, that is about we are saying about point 1, negative 1, 2, it will equal to R, which is the displacement vector at that point with respect to the origin, by F, which is the force vector. Therefore, using the determinants method, we can get this cross product. Therefore, I, j, k, we take 1, negative 1, which is the vector for R and 2, then 3, 2, negative 4, which is the vector for F. Now, using the determinants method, it means therefore I will take I times the determinant of a matrix that is adjacent. If I make a horizontal line here and make a vertical line here, these members will be gone, the members here will be gone, and I will remain with the members of negative 1, 2, 2, negative 4. So I will get I times the determinant of that 2 by 2 matrix minus I minus j. Remember, I take a positive minus positive. That sign conversion is very, very important. So if I take negative j, I'll multiply it by, so I will also create a horizontal line and create a vertical line cancelling j. I therefore take the remaining contents, which will be 1, 2, 3, negative 4. So it means I will multiply j by the determinant of the 2 by 2 matrix 1, 2, 3, negative 4, then plus k times the members. If I make a vertical line here and create a horizontal line here, it means these members will go remain with k times the determinant of a matrix that will remain, which is a 2 by 2 matrix of 1, negative 1, 3, 2. So that means if I look for the determinants and multiply, that will be negative 1 times negative 4. In other words, to get the determinant of a 2 by 2 matrix, I'm getting the products of the major diagonal contents minus the product of the minor diagonal. So the major diagonal is negative 1 and negative 4, and the minor diagonal has 2 and 2. So it will be negative 1 times negative 4 minus 2 times 2, which are the contents of major diagonal. This is minor diagonal. The same thing with the rest. 1 times minus 4, then take away 2 times 3. The same thing is 1 times 2, take away 3 times negative 1. So at the end of the day, R by F, which is the moment of this force, will give you, if I sum here, I'll get 0I plus 10J plus 5K, and this is going to be 10J plus 5K, and the units, of course, for moment is Newton meter. So now, if they ask me the magnitude of the moment, I'll just take the modulus or the magnitude of the cross product of R and F. So the magnitude or the modulus will be, if I take the square root of the square of the x component plus the square of the y component plus the square of the z component, will give me the modulus of this particular vector. Therefore, the components are 0 squared plus 10 squared plus 5 squared. I take root, and this will be 11.18, which is the square root of 125. Now, to look at part C, which requires us to find the directional cosines of line joining 4, 3, negative 5, that is point P, and 2, negative 2, 1, and negative 8. So, for me to get vector P2, I always get 2 minus P. So, which means I'll get 2, the vector for 2, negative 2, 1, negative 8. I take away the vector, column vector for P, which is 4, 3, negative 5, and this gives me negative 6, negative 2, negative 3. At the end of the day, it means the vector P2 is negative 6i minus 2j minus 3k. Now, what if I take the magnitude, therefore vector P2 will be this one, and its magnitude will be the square root of this component squared, this component squared, this component squared, which will be minus 6 squared plus minus 2 squared plus minus 3 squared, everything under a root. So we find that this is equal to the square root of 49, which is equal to 7. Now, what do these things mean? The direction cosines are always cos alpha, cos beta, and cos gamma. And these are angles with which this line P2 makes with the x-axis, the y-axis, and the z-axis respectively. So the directional cosines help us to determine the angle with which that particular line makes with the x-axis, the y-axis, and the z-axis. So for us to get those angles, remember, this is, let us assume this is the x, this is the y, this is the z. So if this is, for example, the line P2, they want you to determine the angle with which this line P2 makes with the angle with which it makes with the x-axis, that is alpha, the one it makes with y-axis, which is beta, and the one it makes with the z-axis, which is gamma. So that means for us to get those directional cosines, we must know the relationship. We know cos is equal to adjacent over hypotenuse. Now the hypotenuse is going to be the modulus of that line P2. So the modulus of line P2, then the adjacent will be by how much is that line moving in the z-axis or in the x-axis or in the y-axis. So if the vector P2 is equal to negative 6i minus 2j minus 3k, it means therefore, let us confirm from up here, yes, it is minus 6j minus 6i minus 2j minus 3k. It means in the y-axis it is going to be, in the x-axis it is going to have a magnitude or a distance of negative 6 in the x-axis. So the adjacent of that angle is going to be negative 6, and the hypotenuse will be the length or the modulus of that vector, which is 7. So that's why we are saying cos alpha, which is the cos of the angle it makes with the x-axis, is equal to negative 6 out of 7. Likewise, cos beta is equal to negative 2, because you have to move negative 2 units in the y-axis. Then to get the adjacent of the angle beta, then the hypotenuse will be the modulus, or the length or the magnitude of vector P2, which will be therefore cos beta will therefore be negative 2 out of 7. And likewise cos gamma, which is the cos of the angle with which it makes with the z-axis, it will be negative 3 out of 7. Thank you so much for watching. See you in the next discussion.